What is the specific problem that the proposed method, ImageInWords, IIW, aims to solve in the field of vision language models, VLMs?
The specific problem that the proposed method, ImageInWords, IIW, aims to solve in the field of vision language models, VLMs, is the limitation of current VLMs that are trained using large, noisy web datasets with alt-text descriptions from the Internet. These alt-text descriptions are often ambiguous, incomplete, and prone to hallucinations, which hinders the model's capabilities in understanding and describing images accurately. IIW addresses this issue by introducing a human-in-the-loop framework that combines the quality of human annotators with seeded metadata from machine generations to curate hyper-detailed and hallucination-free image descriptions. The method focuses on generating detailed descriptions for individual objects in images, refining them through human annotations, and then creating a comprehensive image-level description. IIW aims to provide more specific, comprehensive, and human-like image descriptions compared to existing datasets, ultimately improving the quality of data for VLM training and fine-tuning, leading to better performance in various downstream applications such as text-to-image models and assisting people with visual impairments.
How does the proposed method, ImageInWords, IIW, work, and what are the steps involved in its methodology? Please illustrate step by step.
The proposed method, ImageInWords, IIW, works by combining human annotators with seeded metadata from machine generations to curate hyper-detailed and hallucination-free image descriptions. The methodology involves several steps. 1. Object detection. Object detectors first identify individual object instances in the image. 2. VLM object captioning. A vision language model, VLM, generates granular captions for each detected object, which seed the human annotation process. 3. Human annotation. Crowd workers augment and refine the object-level captions to make them richer and hallucination-free. 4. Image-level captioning. An image caption is generated by the VLM to seed the final image description. 5. Contextual gap filling. Crowd workers use the image-level seed captions along with object-level human annotations to fill in missing contextual information. 6. Iterative process. The annotation process is iterative to ensure a final high-quality dataset. 7. Guidelines design. Guidelines are designed for crowd workers to attend to concepts beyond objects, such as visual perspective, spatial arrangement, and human-object interactions. 8. Dataset construction. The IIW dataset is constructed containing 9,018 images, each with hyper-detailed descriptions. 9. Evaluation. The dataset is evaluated through side-by-side human evaluations against other datasets, showing higher quality and specificity. 10. Fine-tuning. The dataset is used as a fine-tuning dataset for a Poly 3.5b model, resulting in superior readability metrics and improved image descriptions. 11. Downstream applications. The detailed descriptions generated by IIW are used for text-to-image (T2I) models and in applications for people with visual impairments. Overall, the ImageInWords methodology involves a collaborative process between human annotators and machine-generated metadata to produce detailed and accurate image descriptions.
What are the theoretical or practical benefits of using the ImageInWords IIW method compared to existing methods for curating image text data?
The theoretical and practical benefits of using the ImageInWords IIW method compared to existing methods for curating image text data are significant. The IIW method combines human annotators with machine-generated metadata to curate hyper-detailed and hallucination-free image descriptions. This approach results in annotations that are more comprehensive, specific, and human-like, with fewer hallucinations and better leading sentences. The IIW dataset contains more information per description compared to other dense description datasets, with an average of 9. 8 sentences and specific counts of nouns, adjectives, adverbs, and verbs per description. The IIW method also involves a human-in-the-loop framework that iteratively refines image descriptions, ensuring a final high-quality dataset. Furthermore, the IIW method outperforms existing methods in fine-tuning models for generating hyper-detailed descriptions. Evaluations show that models fine-tuned on the IIW dataset produce superior results in terms of readability metrics, human SXS evaluations, image reconstruction, and compositional reasoning tasks. The IIW fine-tuned models exhibit higher comprehension, specificity, TLDR quality, and human likeness compared to models fine-tuned on other datasets. Additionally, the IIW method promotes a more efficient annotation process through sequential augmentation, where annotators build on previous annotations, resulting in higher quality outputs in less time. Overall, the IIW method offers a more effective and reliable way to curate image text data by leveraging the strengths of both human annotators and machine-generated metadata. The detailed and high-quality annotations produced through the IIW framework have practical applications in various downstream tasks, such as text-to-image models, applications for people with visual impairments, and vision-language compositional reasoning.
How was the method ImageInWords IIW validated or tested in the study?
The method ImageInWords IIW was validated and tested in the study through a series of comprehensive experiments and evaluations. Firstly, the IIW dataset was constructed, containing 9,018 images with hyper-detailed descriptions, which were compared to other dense description datasets to showcase its richness and depth. The quality of the descriptions was evaluated through a side-by-side SXS, human evaluation against human-generated datasets, DCI, DOCCI, and GPT-4V, where IIW descriptions were rated as more comprehensive, specific, human-like, containing fewer hallucinations and having better leading sentences. Additionally, the utility of the IIW framework was assessed by fine-tuning a Poly 35B model on the dataset and conducting 4 evaluations to compare it against other fine-tuning sets, showcasing superior readability metrics, preference in human SXS evaluations, and higher reasoning accuracy in compositional reasoning benchmarks. Furthermore, the study included experiments on automatic readability measurements, human SXS evaluations, fine-tuning VLM models, reconstructing images with IIW descriptions, and compositional reasoning with IIW descriptions to comprehensively validate the effectiveness and quality of the IIW method. The results of these experiments demonstrated the superiority of IIW in generating high-quality image descriptions and its potential for advancing vision-language research and applications.
What specific results were achieved with the ImageInWords IIW method in terms of description quality and model fine-tuning performance?
The ImageInWords IIW method achieved significant results in terms of description quality and model fine-tuning performance. Specifically, the IIW dataset contains hyper-detailed descriptions with an average of 8 sentences, 52, 5 nouns, 28 adjectives, 5 adverbs, and 1 verbs per description, surpassing other dense description datasets. Human evaluations rated IIW descriptions as more comprehensive, specific, human-like, containing fewer hallucinations, and having better leading sentences compared to DCI, DOCCI, and GPT-4V descriptions by an average of plus 66%, DCI and DOCCI, and plus 48%, GPT-4V. The IIW fine-tuned model outperformed models fine-tuned on DCI and DOCCI in terms of readability metrics, human SXS evaluations, and downstream tasks like text-to-image T2I, model image reconstruction. The IIW model generated outputs were preferred by plus 31% compared to models fine-tuned on prior work. Additionally, the IIW descriptions aided in vision-language compositional reasoning tasks, showing improvements in accuracy compared to other models, particularly in aero-visual genome attribution and relation, VGA, VGR, and Winogrand datasets. Overall, the IIW method demonstrated superior description quality and enhanced model fine-tuning performance across various evaluation metrics and tasks.
What are the limitations or drawbacks of the ImageInWords IIW method mentioned in the paper?
The limitations or drawbacks of the ImageInWords IIW method mentioned in the paper include the subjective nature of detailed image description annotation, the potential for human annotator bias or errors, and the time-intensive nature of the annotation process. The paper acknowledges that describing images in detail is a highly subjective and complex task, which can lead to variations in the quality and style of annotations produced by different annotators. Additionally, the reliance on human annotators introduces the possibility of errors, inconsistencies, or biases in the annotations, especially when dealing with nuanced visual details. Moreover, the iterative nature of the annotation process, where multiple rounds of refinement are conducted, can be time-consuming and resource-intensive, requiring significant human effort and supervision to ensure high-quality outputs. These limitations highlight the challenges associated with creating hyper-detailed image descriptions using a human-in-the-loop framework like IIW, emphasizing the need for careful management and quality control throughout the annotation process.